Day 3 of 90. Welcome back to the Python Security Scripting Challenge. Yesterday we covered strings and data types. Today we get into file I/O, and this is where security scripting starts to feel like actual security work. Every investigation I have been part of starts with reading files. Suspicious binaries, server logs, config files, memory dumps. Python gives us precise control over all of it, so let us get started. Our first task is reading binary files for forensic triage. When you find a suspicious file on a compromised host, step 1 is always, do not modify it. Open it in binary mode with RB. Binary mode prevents Python from doing any new line translation or encoding conversion, so you get the exact bytes on disk. From there we compute a SHA-256 hash for chain of custody. This hash proves the file has not been altered since you first touched it. Then we extract printable ASCII strings. We iterate over each byte, collect characters in the printable range 32 to 126, and save any sequence of 4 or more characters. This gives you the same output as the Linux strings command, but entirely in Python. No subprocess call, no dependency on the host having strings installed. On a compromised box, you cannot trust any installed binary, so doing it in pure Python is a real advantage. Next up, parsing log files. Two logs you will hit constantly in incident response are auth.log for SSH brute force detection and Apache access logs for web attacks. For auth.log, we write a regex that matches the failed password line format, extracting both the username and the source IP. We feed every match into a counter to get frequency tables. In one pass through the file, we know which IPs are hammering the SSH service and which usernames they are targeting. For Apache logs, the combined log format gives us IP, timestamp, HTTP request, status code, response size, referrer, and user agent. We parse each line with a regex, then check the request string against a list of attack patterns, directory traversal with .. SQL injection keywords like union and select, script injection with angle brackets, and path traversal targeting password or shadow files. Every match goes into an alerts list with the source IP and matched pattern. Now let us talk about file hashing for integrity monitoring. Chain of custody starts with hashing, but hashing is also your first line of defense for detecting unauthorized changes. We write a function that walks an entire directory tree, computes SHA-256 for every file using chunked reads of 8,192 bytes. Chunked reads keep memory flat even on multi-gigabyte disk images or database dumps. We store the results as a JSON manifest. Run this once on a clean system to get your baseline. Then run it again later and diff the two manifests. Any changed hash means that file was modified. This is how you catch an attacker who edits a cron job, modifies an SSH authorized keys file, or plants a backdoor in a system binary. No fancy tool needed, just hashlib and os.walk. Wrapping up with two more techniques. First, safe file handling. Security scripts often process untrusted input, so always use context managers to guarantee file handles close even when exceptions fire. Use tempfile.name temporary file when writing sensitive intermediate data so it does not linger on disk after your script exits. Second, enumerating/proc for live forensics. On Linux, every running process has a numbered directory under /prop read /proc/pid/command line to get the full command line and read link /proc/pid/exe to get the actual binary path. This works even when an attacker has replaced PS, top, or other userland monitoring tools with Trojanized versions. The /proc file system comes straight from the kernel, so it gives you ground truth. That is day 3. We covered binary file reading for forensic triage, log parsing for auth.log and Apache access logs, file hashing with SHA-256 for integrity baselines, safe file handling with context managers and temp files, and process enumeration through the /proc file system. Every one of these techniques uses only Python standard library modules. No pip install required. Tomorrow on day 4 we get into networking with sockets, which builds directly on these file I/O skills. See you then.